Right, well the central limit theorem said that if you make things big enough, they should eventually be described by a Gaussian distribution, a normal distribution, or a Poisson distribution, same thing. We've seen that the internet has got 25 billion sites in it, and it's still not described by that distribution. It's described by a power law with index about 2. So the question is, if we believe the central limit theorem, and we do, how big has the World Wide Web got to get before it's described by a Poisson network? In other words, a network describing the road system rather than the airline system. Well, the answer is it's given by that number. And I only put that number up because it contains things which you will know and recognize. It's got the number pi in it. It's got the logarithm, so it's got the number e in it. And n here is the size of the internet, the number of sites in the internet. And this number has to be close to 1. So we've got a 1, and we've got this bit here, which is described by this f of n. If we take a look at it, it's actually quite strange, because these bits are just a number, but here we've got the log of n. Now, if you've ever played with your calculator, put numbers in there, you'll see that the log is a very, very slowly varying function. If you take the logarithm of, let's say, e to the 100, e to the 100 is an enormous number. It's 1 followed by about 50 zeros. Take its logarithm, it becomes 100. Take the log of 100, you've got a number less than 10. So you've gone from something bigger than 10 to the 50 to something less than 10 in just 2 steps. You've then got to divide by the log of n as well. So what this is showing is that this is a very, very slowly varying function. N can get very, very large indeed. That's in fact what that function looks like. So there's the number 1 where it's got to hit. And what I've plotted along here, notice it's a logarithmic axis, but it's not n, it's the log of n. Okay? So that number's got a bump there, and that bump corresponds to about 5,000. Well, we know that there are 26 billion sites in the internet, so we're over that hump. If we want to get to within 1% of that curve, then how big have we got to take it? Well, it's very, very slow indeed. In fact, you need a number 10 to the 25 to get within 1% of its target 1. Now, 10 to the 25 is a big number. How big? Well, let's go back to our example of throwing a dice. Imagine that we throw a dice once a second. After 10 throws, we saw something which looked like a normal distribution. So in 10 seconds, we would have got to a situation where the central limit theorem would work. Now let's imagine that we add a new site to the internet once a second. Okay? Well, the time since the Big Bang is about 5 times 10 to the 17 seconds ago. So that would tell us that the World Wide Web would in fact become a Poisson network in about 100 million times the age of the universe. So you can keep on clicking and using the internet as you can do at the moment. It's not going to change its character for an enormously long time. I mentioned Kevin Bacon. Is he really the most connected actor of Hollywood? Well, the answer is no, he's not. Number 1 is Rod Steiger. Anyone know who Rod Steiger is? Anyone seen him? Well, he's dead, of course. So, and that's the key again. He's old, he's dead, he was around for a long time, he had lots and lots of co-stars. Number 2 is Donald Pleasance. Anyone know him? It's always the older people in the audience who... in fact, Donald Pleasance has been a Blofeld villain and many, many other things. Martin Sheen, how about Martin Sheen? Yeah, well, he's the president in the West Wing, so he's pretty well connected. Number 12 is James Earl Jones. Anyone know who he is? Well, in fact, he's the voice of Darth Vader, not Darth Vader himself. And what about Kevin Bacon? Well, he's actually way down in the 800s or so. So, if we think of Hollywood as being some sort of fractal network, the big hubs, the big beasts in our fractal jungle, are the likes of these guys here, whereas in fact, poor old Kevin Bacon is lost in the weeds. Anyway, if you have been, thanks very much for your attention.